This is the video lesson for 1.1, the lesson of trigonometric ratios in right triangles. In this lesson, we'll be using primary trigonometric ratios to find missing side lengths and angles within right triangles. Recall, a right triangle is a triangle where one of its angles is a right angle, a 90-degree angle. To do this, we use the acronym SOHCAHTOA, which is, well, a made-up word to help us remember the use of the primary trig ratios. Now, there are three primary trig ratios: sine, cos or cosine, and tangent or tan. Now, SOHCAHTOA, this acronym, is used by seeing the capital letters, the S, the C, and the T, as representing those three primary trig ratios. So the capital S stands for sine, the capital C stands for cos, and the T for tangent. The ratio of sides are relative to a reference angle, and we have the symbol for the Greek letter of theta. Now, before we learn to use SOHCAHTOA, let's look at some definitions. There are three primary trig ratios: sine, cos, and tan, and also three labeling of the sides of a right angle triangle. Looking at the diagram on the right, the three sides of a right angle triangle are labeled as the hypotenuse, the adjacent side, and the opposite side. Now, a quick note on where each one is labeled. The hypotenuse is always the longest side of our right angle triangle, and it's also always the side across from the right angle itself. If my right angle, my 90-degree angle, is here, my hypotenuse is the one furthest from it, across from it, and it also will be the longest side. This would be the side we could find using the Pythagorean theorem in the previous lesson. A squared plus b squared is equal to c squared. We used to find the hypotenuse. That's still the hypotenuse for these trig ratios. Now, the opposite and adjacent side depend on where the angle theta is. So next, look and locate where the angle theta, that Greek symbol, is located. The opposite side length is the side literally opposite from that angle or far across from it. The adjacent side length, the word adjacent in general means next to or beside. For example, your next door neighbor in the house living beside you is the house adjacent to you. So the adjacent side is the side right along, right beside where that theta is labeled, but not the hypotenuse. The hypotenuse is always that longest angle or side across from the right angle. So we have the hypotenuse, the opposite side, and the adjacent side. Now, the three formulas for sine, cos, and tan are as follows. Sine of the angle theta is equal to the opposite side divided by the hypotenuse. Cosine of theta is equal to the adjacent side divided by the hypotenuse side. And when I say divided by, I mean the lengths of those sides being divided. And finally, tan of theta is equal to the opposite side length divided by the adjacent side length. Looking back at SOHCAHTOA, that acronym is used to help memorize these three formula. So sine is equal to, or sine of theta is equal to opposite over hypotenuse. Look at the first letter in those three words. Sine theta is equal to opposite over hypotenuse. That's summarized by the SO, S-O-H, in SOHCAHTOA. Ka, C-A-H, that's used to memorize cos of theta is equal to adjacent over hypotenuse. So cos CAH, cos theta is equal to adjacent over hypotenuse. And finally, TOA, T-O-A, is used to remember tan of theta is equal to opposite over adjacent. Examples. Label each side of the triangle relative to the reference angle theta. It is important where the theta symbol is drawn. In example A, the theta is in that top angle. I would always start by labeling the hypotenuse first. The hypotenuse is the longest side of the triangle. It will always be across from the right angle. My hypotenuse is on the angled side here. Now my opposite side is the side literally opposite or across away from the angle theta. And finally my adjacent side is the one right beside the angle theta. So in example 1a we can see where we label hypotenuse, opposite, and adjacent sides. Example 1b. Again, look at where theta is located. You can always start by labeling the hypotenuse, which will be that angled side. The opposite side is opposite from the angle theta, and the adjacent side is on the bottom, in this case, that side right beside the angle theta, but not the hypotenuse one. Example 2. Write each of the following ratios for this triangle on the right. Now look at my diagram. I have triangle ABC, and I have side lengths 3, 4, and 5. If you'd like, you can check with Pythagorean to make sure that this is a right angle triangle. You don't really need to because it is labeled, but a squared plus b squared does indeed equal c squared. 3 squared plus 4 squared has to equal 5 squared, and it does. Looking at example 2a, what's the value of sine of a? Now to find this, first we have to recall what the formula for sine of an angle theta, or in this case a, is equal to. And sine, so, in SOHCAHTOA, sine theta is equal to, once again, opposite over hypotenuse. So in this triangle, where's the opposite side and where's the hypotenuse? Well, the opposite is opposite of the given angle, and they're using angle A. So look where angle A is in our diagram. The side opposite of A is the value 3. So opposite is 3. The hypotenuse is certainly 5. So sine of A, opposite over hypotenuse, is 3 over 5. 3 divided by 5, or just 3/5. Example 2b. What's the value of cos C? Now the formula for cos is adjacent over hypotenuse. What side is adjacent to angle C? Well, the side adjacent to angle C is, again, the side with length 3. Because now we're looking at a different angle. The theta, or in this case C, the angle has changed. 3 is adjacent to angle C. We need adjacent over hypotenuse. The hypotenuse is still 5, so my equation for cosine of C, which is adjacent divided by hypotenuse, is 3 divided by 5, which happens to be the same answer as part 2a. That's okay, because we not only switch the trig ratio from sine to cos, but we also switch the angle itself. We were looking at angle A, and B we were looking at angle C. Example 2c. Calculate tan of A, still for the same triangle. Step 1. What's my formula for tan? Tan is equal to opposite over adjacent. For angle A, what is my opposite? What is my adjacent? For angle A in my triangle, my opposite is 3. My adjacent is 4. So tan of A is equal to 3 divided by 4, or 3/4, 3/4. And finally, example 2d. What is the value of sine of C? Step 1. What is my general equation for sine? Sine is equal to opposite over hypotenuse. For angle C, what is my opposite? What is my hypotenuse? Now the opposite side for C is the length of 4. That's the side opposite across from angle C. My hypotenuse is still 5. So sine of C is equal to 4 over 5, or 4/5. Example 3. Determine the reference angle. In this case, you're given the ratio that we were finding in the previous example 2, and now asked to find what angle we are talking about. Example 3a. Sine D is equal to 5 over 13. What is the value of D? So 5 over 13, looking at my triangle, I can see I have triangle DEF, and they're giving me a value of sine. Now for this, we're looking for what the letter is, so assume that the red letter we have to find. The answer is D, but how did they get D is what we're trying to locate. So sine of what is equal to 5 over 13? Well, the equation for sine, looking up again and using SOHCAHTOA, is sine is equal to opposite over hypotenuse. 5 over 13 is therefore opposite over hypotenuse. So from which angle's perspective is 5 the opposite side and 13 the hypotenuse side? Well, 5 is opposite of angle D. So 5 over 13 is sine of angle D. So the answer to 3a is D. Now it's a little tricky to view these because the answers are already filled out, but assume that you didn't know what the capital letter in the brackets are. That's what we're trying to find for these. Example 3b. Cos of what angle is equal to 5 over 13? Well, cos is adjacent over hypotenuse. From what angle's perspective is 5 the adjacent and 13 the hypotenuse? That would be the case from angle F. 5 is adjacent to F, 13 is hypotenuse. So B, the angle we are talking about, is F. C, tan of what angle is equal to 12 over 5? Now the formula for tan is opposite over adjacent. From which angle's perspective is 12 the opposite and 5 the adjacent? That would again be from angle F's perspective. And lastly, 3D, tan of which angle is equal to 5 over 12? Again, tan is opposite over adjacent. So from which angle's perspective is 5 opposite and 12 adjacent? 5 is opposite to D. 12 is adjacent to D. So that would be the case from angle D.